so we are going to do a very quick overview today. It'll be fast and furious, but feel free to reach out to us afterward if you have questions or want to discuss this with us further. We've got all code available, and of course, this video will be made available afterward as well. My name is Jennifer Reif, and
I'm Mark Heckler, and we're happy to be here with you today.
Yep. So I'm a developer advocate at Neo4j. I like writing code, and then I like sharing that and kind of sharing my learning process or kind of what's behind it through technical writing. So I write a lot of blog posts, I speak at a lot of conferences or virtual events. And then just outside of that, I'm just kind of a geek in general. Most things geek I kind of enjoy. So.
And I'm Mark Heckler. I'm a principal cloud advocate of Java and JVM languages with Microsoft. Also picked up a few awards and honors along the way: Java Champion, Java 1 Rockstar, Groundbreaker Ambassador, Kotlin Developer Expert. Wrote a book, which you see there, and I'm a licensed instrument rated pilot, which I don't think we talk about today, which is a real shame, but oh well, you know, such is life.
Yeah. So a little bit on this session, again, it's going to be a bit of a whirlwind, but we are going to kind of dip our toes into the water of using Spring AI. And this is going to bring AI to Spring applications, if the name doesn't hint at that already. They have both implementations for OpenAI as well as Azure OpenAI. And it takes text-based prompts and turns it into language or code for return results. We're going to use the technique called prompt stuffing. There's also one called fine tuning, but we're not going to go quite that deep and integrated yet. So we're just going to kind of stick with the prompt stuffing, and we're going to do that through retrieval augmented generation, or RAG. If you see that term quite a bit when you see things about knowledge graphs or LLMs, what it's going to do is provide context and guidance for the LLM to return more contextual and valid results and verify the results so that there's less chance of hallucination there.
And I will say that we do a lot more things that we're not going to be able to cover today, which is kind of a shame, but that's why we want you to check out the repo and just to ping us after the fact, because there's a lot of things that go into various different aspects of working with AI in one form or another. And we don't cover them all, but we cover a lot of the high points. But within this very short session today, we cover maybe a select few of those high points. So if you want to talk about this at length after the fact, please do reach out. We're happy to discuss.
Absolutely. So Neo4j is going to be used as a vector database and to add that data context. So we added vector search capabilities to Neo4j earlier in the year. I should say Neo4j did. And it's going to help us ground the LLM answers by using the connected data stored in the graph. So you're going to have a prompt. It's going to be used to feed a query, which is going to retrieve graph data, and that all is going to be fed to the AI. So the typical steps, you would calculate vectors or store embeddings in Neo4j. You would have the prompt that then would get calculated up and sent over to the AI with the data, the graph data. And then it would compare the data that's in that prompt to vectors stored in the LLM, return the most similar. If you want to know more about Neo4j vector search or the capabilities that are available there and how that works, feel free to check out the link. Again, the slides will be made available, and you can click the link and learn more about how Neo4j is using vectors in their database. So without further ado, let's dive into some code.
Okay, so as Jennifer mentioned, this is kind of a whirlwind tour. So we are trying to be very judicious with the time. Ooh, we've got the inception thing going. And once again, let me switch. There we go. And we're going to try to hit the high points. Again, a very select few of the select few points that we can cover. But the conversation is good. Our goal today is not to show you everything, but to get the conversation started so that we can have a great conversation about this and develop things as we go. So I'm going to start off with the Spring Initializer. This is kind of where you start to build Spring applications. You don't have to, but this is a great jumping off point. So we'll use it. We love it. And we're going to use Maven and Java for our build system and our language, which are kind of middle of the road choices, good choices, but you have options. Using the current version of Spring Boot, which is 3.1.5, I'm going to change this to the hecklers because why not? I can. And we'll make the artifact name a Neo AI. We'll just make this an AI demo project, and then we'll choose just a couple of dependencies to bring in here. We're going to build a very basic, and we do take this a little further in the repo that we share, but we're going to build today a pretty streamlined version of that AI application, AI-enabled application So we're going to build an API here, a REST API, and we're going to incorporate Neo4j, of course, to do that. And we'll make this AI enabled as we go. So I'm going to generate this this project, and we'll just drop that on the desktop, and we'll open that up. I'm going to just go out here to kind of looking around things, but we should have that here now. So yep, we have that. Let's go ahead and unzip that, and we'll change directories into there. And then I'm going to open that up in IntelliJ IDEA. Use whatever works best for you. I spend a lot of time in VS Code, as you might imagine, working at Microsoft, and VS Code is an awesome, awesome IDE. I also spend a lot of time in IntelliJ, and Jennifer and I have worked together on in IntelliJ on this, so that's the path we'll take today. So I'm going to start first by going to the POM, which is the Maven build file. And I'm going to add a couple of dependencies that aren't already in there, that aren't available via the Spring initializer. So let's see if I can, yeah, the Spring AI dependency, kind of important if you're going to be doing a Spring AI application. And of course, we'll need to access our snapshots repo, so we can bring that all the goodies in, because this is an experimental feature at this point. It's not production ready. So we're getting a very early look, and we're sharing a very early look, which is kind of cool. We don't necessarily need to put anything in the application properties. We have everything externalized, as most good developers should, right? And then let's go ahead and go to our main application class. This is, as it stands, the working Spring Boot application. It doesn't do anything yet, but it does work. So I guess that's a good start. In the interest of time, I am going to just bring in a couple of existing domain classes and repository classes and what have you, because I don't want to spend a lot of time focusing on the minutiae. What I want to do is save the time for the really good stuff. So I'm going to go ahead and bring in a few things here. Let's go ahead and pop over to here. Let's drop those into there, and let's see what we get. And I'll walk you through these very quickly, but it's faster than just even addressing them at a very high level. So you typically, when you create an application, you start with a domain, right? I hope we start with the domain. Okay, anyway, so we defined our domain, and we have categories of different pet-friendly accommodations and offerings within a particular geographical area. So we have categories, generally very broad categories. Within those categories, we break them into subcategories, and each category can contain multiple subcategories, right? And a subcategory can fall within multiple different categories, yeah. And then within these subcategories, you have places, so things like veterinarians and dog parks and restaurants and pubs and hotels that accommodate pets and things like that. And of course, Jennifer did a lot of the heavy lifting in terms of the data, because she went out and combed through various different public APIs and sources to collect a lot of this data. And I'll talk about this more as we go throughout, but one of the, I guess, limitations with public-facing AI offerings are that typically they do a cutoff of 2 years back. So you don't always get the freshest of data. And in things where you want to be fresh, where you want to be current, like, is there a restaurant that allows me to bring Fluffy with me to have lunch and when I'm visiting New York City next week? Restaurants can come and go very quickly. So we want to have as timely information as we can. And there are a couple of use cases with AI. Many times folks train and use the AI solely on their data, or they solely use public data. We're actually blending the two. So that's kind of I think a fun application, because we use what we know to be as current as possible to inform the data that we're pulling back from the AI. So sorry for the little diversion there. So we have our category, subcategory, and places, and then we're going to be focusing on the place repository. Now, Jennifer was also kind enough to do some really nice query building here using Cypher. So I defer to her Cypher wizardry here, and that gives us, again, some very basic building blocks for the purposes of our demo today, in which we can search for a particular category of pet, or a particular place, a type of place in a particular location. And that gets the bulk of the setup out of the way. So the one thing that we do want to do is, as I mentioned, we want to somehow use the documents that we retrieve, the information we retrieve, to inform the AI search that we're going to be doing. So what I like to do is create a directory here under resources available to our application. I call this prompts. Clever, right? And then I want to create a file here that I'll call system.st. And typically you can have multiple different prompts that you can use to help craft the query that you're feeding to the AI. And again, we're streamlining this. We have one today, but you certainly have the option to build quite a few. And this is kind of what this looks like. We want to feed this to our AI queries saying, you are a helpful pet-loving assistant that suggests and explains pet-friendly travel locations to your users. And this is where I mentioned that we kind of blend things. Prioritize places listed in the document section below first, but include as much additional information as possible. So in other words, if we've been able to find via public APIs current restaurant information for some, a small suburb in Cleveland, that's great. But if we haven't, please supplement that. Or even areas where we have found different public references, maybe supplement that and fill out things that perhaps an AI might be able to sift out that we missed somehow, via a hidden API or maybe something buried on a web page or something. So this gives us a way to get started. Now, I'm going to focus again on a couple of things that are key to our mission here today. And I'm going to first create a vector store, Neo vector store class, vector store, typing hard. Store, and we'll make this a class, right? And I'm just going to extend the vector store interface. And of course, in order to do that, I have to do a couple of things. One, I import that reference, and then I also need to implement. Got ahead of myself there. We need to provide an implementation of a few methods here. So we're not going to be using some of these. Again, we're not going to be adding documents. Thanks to Jennifer for pre-populating, but we might do something. I'm just going to comment this. What we might do is something like a repo save all. And of course, to do that, we have to have access to the repository. So I'm going to just inject our place repository here in a constructor injection, which is the right way to do it in a Spring Boot app. And if we were to add documents, this is how we would do it. We don't have to delete any documents today, so I'm going to skip blithely over that, but we will be using something in terms of our similarity search. So for our similarity search, I'm reaching everywhere for my mouse. We switched the mouse around for today, so if I do this, that's why. So I'm going to, the first thing you notice is we return a list of documents, and a document is kind of the building block that we're going to be using to feed data to our AI search. So I'm going to create a list of type documents here. We'll call this cleverly enough documents. And yes, thank you, Copilot, for suggesting exactly what I wanted. Very nice. So we're going to create a list of documents, and then I'm going to use our repo, and I'm going to do a find in category and feed it our query. I'm going to take that and just grab the iterator from it. And then for each one, I'm just going to add that information from each place that we retrieve into a document. And then I'll just return the documents. And that looks pretty good. Now, the one thing that I do want to do is, if you notice, these are overridden methods defined in vector store, but I do want to add the capability to take advantage of that other really nice query that we have built, or Jennifer has built, and feed it type and location, so we can do something with that. And this is pretty easily done, really. We have another method built, thank you, Jennifer, so that we can just do a find in places and pass type and location, and basically do the same operation. And we're going to use that later. I can do some minor changes here. I'm just going to, in this case, create a couple of things here. I'm going to create a list of documents here, var documents equals typing hard, and I'm going to call the similarity search using the same query that we're passing in, and then I'm just going to return documents.sublist and take the sublist here, starting with 0, and return the minimum of either the requested size or the total document size. So if you request 10, but there are only 3 coming back, you can only provide 3. So we'll clean that up. And that looks pretty good, except for some reason that's barking at me. That's so rude. Oh, yeah. There we go. Yeah. So particular. And I'm not really going to do anything with this. So I think I'm just going to, oh, this is easy. Why not? Just return similarity search. And we'll just pass it a threshold of a 0, double 0. So that's fine. We're not going to use that anyway. I just wanted to make sure that it didn't bark at me when I tried to use it later, or tried to use the other things later. The next thing I want to do is just create, we have our vector store. Now what I want to do is create our RAG service. So RAG service, and we're going to make this a service, right? So this will fire up upon application initialization, and we should be off to the races. I'm going to inject our, not our place repository repo, right? And there we go. And the only thing that we really need to do at this point is, thank you, Copilot, is to create a retrieval method to retrieve a generation, an AI generation. And we're going to pass it our prompts. And of course, it's telling me there's a problem. Let's go ahead and import that, and let's fix some of these problems. So we're going to pass in our prompts, which are, it's a map of strings and objects, right? And I'm actually going to be using hash map in this case. There we go. That looks pretty good because we're going to have keys of type string and any kind of object as our values. And that's this is maybe a little lacking. Let's probably do a little bit more than that. So I'm going to create a variable called vector store equals new Neo vector store, and we'll pass it our repo so it can use that. And that looks pretty good. And now I'm going to, it's offering me some weird things here, but we'll just do a type string here equals, and we'll see if it, that looks pretty good, right? So if we pass in a type, we'll use that type. Otherwise, we use hotel for our type. And then if we have a location string, and look at that. We'll default to New York if we get no location. I like to make sure that we cover our bases in case something doesn't come through properly, and that way our application just doesn't blow up. That seems to be a good thing, right? So we're going to put those prompts, or put those documents that we retrieve from our vector store using a similarity search into our documents, right? And then we will create a system message, and actually I need to do one thing before I can do my system message. Because if you remember, we created a prompt, right? Or actually our prompt, yes. And this looks pretty good. Thank you for that. So private, and it is a resource. Yes, so we need to bring this in as a resource, load this up, and we will take that, our system message, and we will use a system prompt template, right? And we will use our system ST. We'll create the message from that using our prompts. And for some reason, that's, oh yes, I should do that, right? New system prompt. I get ahead of myself sometimes. That looks happier. That looks much happier. At this point, we just need to return, I didn't inject my my AI client. I get so excited sometimes I just can't help myself. So AI client, and then of course we'll want to inject that in our constructor, and that looks pretty good. So return, and we'll use our AI client. Did
you just call it client?
I may have.
You did.
I did. Let's fix that. AI client, and
that's happier.
Oh, that that's fine. I could have gone the other way. Probably should have gone the other way. It would have been a little faster. This dot AI client equals AI client. Sometimes manually doing it just works, right? So we'll go ahead and create our AI prompt from this, and we will generate this, and it seems like it should work.
Yeah.
Don't you think? Why not?
Let's give it a shot.
Okay, so I'm going to go back here, and I'm just going to do a straightforward build using Maven W Spring Boot run. Actually, not I build, a run, right? And then hopefully that will work. Oh, yes, I did actually. I brought over the controller class, so that saves a little bit of time. I don't have to code that. And again, we're keeping it simple here locally, and I'll show you a little bit more of the finished application. I hesitate to call it polished. What did I do? What did I leave out? We'll take a quick look. Exception encountered, canceling refresh attempt, unsatisfied dependency.
Oh, it couldn't create that controller.
Oh, interesting. Did I not bring that over?
I thought you did.
Controller. Okay, well, that's interesting. That's very interesting. Okay, so let me, we won't need this. We won't need this. Our very basic API. We will need that. Let's do let's go back here. So Maven W clean package. Let's see what we get here. Worst case, we'll skip ahead using existing code that we know works, and we've checked into our repository. We've tested rigorously.
We have backup plans.
Yeah, we do. Always have a backup. Live coding, you know it's live, Lynn. So what did I miss? Failures, error. I know I skipped several things just to try to get things tight and fast and streamlined. Interesting. Found zero Neo4j repository interfaces. Oh, well, that's let's see. So place repository extends Neo4j repository.
That looks good.
And let's see. Wow. So that's interesting. All right. So I will do one more thing here before I just throw in the towel and pull over our existing code from our repo, which is fresh and guaranteed good shelf life. But I do want to, that's just so interesting. So did I
was gonna say it's the package.
Let me see if I didn't inject that properly. So we've got our repo and we've got our controller, which has the rag service and the rag service. Of course, we have that right there. It's just a mystery. So we'll probably find this later and be able to share with you what happened, but I don't want to expend a lot of time on this at the moment. So what I'm going to do is just bring this over and clear this, and we'll run this from here. And that works. It's certainly not my ideal, but it works. So we'll run this locally, and then we'll go ahead and run this in the cloud, and we'll take a look at this. So I'm going to go to the AI endpoint. We'll pass in a type of, what do you want? Pub, and location equals New York. And of course, with Z shell, I need to go back and put this in quotes, keep Z shell happy, and we'll see what we get back. And once that works, because it always works, live coding and live demos always work. So we see that we're getting some results back. This is great. That's very nice. Let's go ahead and go to our cloud here. And this is where we've deployed it to Microsoft Azure. We're using Azure OpenAI as our AI backend, and Spring, of course, in the front, and Neo4j for our vector data store. It all ties together really, really nicely. You can go here to the URL, and you can see that we have, and I can just close this. You can see that we have our floof travel, right? This is so you can take your floof with you when you travel, and this is very fun, right? So I'm going to just search for restaurants, and we'll check St. Louis because that's close to us. And we may not have data for that, but again, the AI tries to supplement with what we have and what we don't have, and just bring in the full Monty. So we have everything here. That looks pretty good. Let's go to veterinarian. That's fine. New York. And we'll search. So we get some, hopefully, veterinarians. Yeah, veterinarian places, animal medical center. If we go to pub in Chicago. Yeah, so I mean, we have, located address listed in the document section. Each time it comes back a little bit differently, but it's very nicely formatted always. It seems to always do a nice job. Restaurant. Let's do restaurant in New York. I got New York on my mind here. So two great options for pet-friendly restaurants, the Greens and Seaport Food Lab, both of which are pop-up restaurants. Very nice. Sounds like it could be fun. So I'm going to turn it over to Jennifer at this point, and we'll go ahead and launch into Bloom and wrap up, and then take questions, and see you in the interwebs.
Yeah. Okay. So let's switch here, and this one, right? And this one. Okay. So just a couple more minutes here, and I will go ahead and clear this. So let's start off with just something pretty straightforward. So this is Bloom. This is Neo4j's visualization tool. It has some pretty nice features. Allows you to search the graph, the data inside Neo4j through natural language queries. So if you don't want to write Cypher all the time, this is a good way to avoid that. So you can see it pops up some nice options for me to choose. I'm just going to go ahead and choose place, and I can either choose specific relationships or go straight to some other entities. So that's what I'm going to do for now. We're just going to retrieve some data. It's taking a minute. There it goes. And I need to fix my layout a little bit. So there's lots of different layouts you can choose from. And it'll take a minute to, there we go, load, because there's lots of data here. So you can kind of zoom in. Oh dear. There we go. Okay, it had to, the force directed layout had to kind of settle itself a little bit. So you can kind of zoom in on this smaller portion of the graph, so it's a little bit easier to read. And you can see we have places here in blue, we have subcategories in red, and then we have higher level categories in yellow here. So you can write queries based on this and retrieve different places around the graph. So next, let's just retrieve some places here. And I want to show kind of one neat thing. So this is a ton of places. And what I actually want to do is, before I get too far ahead of myself, let's zoom in a little bit and do something based on the city that we're looking at. City, and we're going to type in New York, because that's what we've kind of been searching for. So it's going to retrieve 172 nodes here, just kind of showing up. And again, I mentioned there are a few different layouts here. So if we switch to a coordinate layout, you can kind of see it lays it out sort of like a map. And we can kind of zoom in on this just a bit more. And if we say, for instance, there's a limo service right here. This sits down in Manhattan, kind of the lower part of Manhattan. If you were to look this up on Google Maps in New York, and then we could kind of zoom out here a little bit and look at maybe some other places. And if we pull, oh, where did it go? Well, there's some over here. But if you look, this was the one I was looking for. This place right here is, click on it, and it falls over in Brooklyn. If you search this and pull it up, and you can kind of see, if you're familiar somewhat with the way New York City lays out, our limo service is over here. And then our Brooklyn Lismonade places over here. You can kind of see this blank area right there. Well, this is right where the river comes through between Manhattan and Brooklyn. So again, kind of neat. You can kind of see that map. If you were to actually overlay this data onto a map, probably pretty close. And I just think it's kind of a really neat way to look at the data. All right, so without further ado, let's do cover one more thing, and that is saved cipher. So I've got kind of a cipher query written in here, and that way business folks or those who don't want to try to remember a cipher query every time can just type in a particular search phrase and find the data that they're looking for. So let's do that really quickly here. We're going to look for a place, and you can see the place query comes up, and it's going to give me options to search for different types of places. And I'm going to search for cafe, and then I'm going to search in New York City. Let's see what we get. We get this lovely little graph here. So 3 categories, a subcategory, and 2 places. Now, this is a pretty nice view. It's pretty easy to see because we don't have much data returned here. But one more layout that's kind of neat is this hierarchical layout. So you can see we have 3 categories that feed into the same subcategory, and then 2 places that fall within that. So pretty neat, kind of different way to look at data, whether you're writing queries or kind of organizing the data inside the view, or kind of doing some other things. There's lots of neat visualization opportunities there. So, all right. Let's jump back to our slides and wrap up here, right?
Yes.
Okay.
Good.
So resources.
Yeah. So please check out the repo at, actually, I should have moved it out from under my personal repo, but we'll work on that. And we'll keep a link there. So Neo AI, if you want to know more about the Spring AI project, again, this is experimental, but it's developing quite nicely. Go out and check out the docs here. That's a live link. And then, of course, the website for Neo4j, Gen AI, is out there. Check us out, contact us, email, LinkedIn, follow us on GitHub, follow us on Twitter /X/ whatever it is anymore. And we're happy to carry on the conversation from here on out. Just as a quick recap, what we wanted to do is focus on the key things. So we built the domain, right? The data was in place. Thank you, Jennifer, for doing the heavy lifting ahead of time on that, because that would take a significant amount of time. And then we built the domain and or brought in the domain and the repository. And then what I wanted to do is kind of focus in on showing the vector store and what it does and its use within the retrieval augmented generation. And then to go ahead and pull things out, present it, and then show it, and then show the visualization as you did in Bloom, and to give you a lot of different ways to examine and evaluate your data, or data that you have access to via some mechanism, public APIs, Gen AI, et cetera. So with that, I think we're ready for we're ready to wrap up. But if you have any questions, comments, or feedback, please do reach out to us. Happy to chat.
Thank you.
Thanks.